talk about the normal distribution. The normal distribution is the most famous example of continuous probability distributions. As an example of the normal distribution, we have this example: a Pepsi can is supposed to contain 12 ounces. So the volume of the can is X, and it is here the random variable, and it could be 12, but it might actually contain any amount between 11.9 and 12.1. So for this random variable, X could be any number between 11.9 and 12.1. X could be any number between these two numbers, any real number. X has infinite values. For example, it could be 11.9853 ounces, the volume of the can. So the volume of the can of soda in a can, is here called a continuous probability distribution. So the random variable X here is called continuous probability distribution because the values of X are infinite. You cannot count them. While we studied in chapter 5 examples of discrete random variables. One of the main differences, one of the important differences between discrete and continuous probability distributions here is when you have discrete, for example, you have 100 people, so probability of X equals 75 is there. There is a probability. And there is a probability that X is 76. There is a probability. And there is a difference between probability of X less than or equal to 75 and probability of X less than 75, because X can be equal to 75 and it has a probability. While if you consider the continuous random variable, we have uncountable infinite number of possible outcomes for this random variable. So we cannot give a probability for each value of X. So simply we say that the probability of any one of these uncountable infinite number of outcomes is just 0. So in the continuous probability distribution, probability that X equals any number is 0. And probability that X is less than or equal to is exactly the same as probability of X less than, because probability equals to 11.92 is 0. So please pay attention to this difference between the discrete probability distributions and the continuous probability distributions. Here are 3 examples about the normal distributions. All of these 3 graphs are graphs of normal distributions. Here we have a normal distribution with mean 20 and standard deviation 5. So 20, you can go 5 standard deviations to the right, 25, 30, 35, 15, 10, 5. You can do that, okay, as we learned before. For example, what do we need to ask about this distribution? If I ask you about what is the probability that this X is less than 10, for example. So if this is 10, I'm asking about this area. So this is the area, probability of X less than 10. Notice that if this is 40, for example, here 40, and we go by 20, so this is 20, and this is 0, and this is negative 20. So if I ask you about the probability that X is less than 10 here, in this example, then this would be the probability of X is less than 10. And you can see that this probability or this area, of course, notice that the probability is just the area, in fact. So this area, shaded area, is of course greater than this area. So probability that x is less than 10 could be different from a normal to distribution to another because the mean is different and the standard deviation is also different. Also, the shape of the distribution, if the mean is not the same, so this would be to the right of this would be to the right of this. And if the standard deviation is lower, the graph would be higher like this. And if the standard deviation is larger, there is a much spread, more spread. Okay, the spread here, the variability in this distribution is more than this one because the standard deviation is 20 and the standard deviation here is 10. So if you change mu and sigma, that shape changes, but it's always a bell shaped. It is always a bell shaped. If it's a normal distribution, always it's a bell shaped. And it is always symmetric. Symmetric. So the graph, all of these three are symmetric. Meaning of symmetric means this area, which is to the right of mu, is equal to zero point 0.5, half of the total area. And this area to the left of the mean is also zero point 0.5. So this area is equal to this area exactly because the graph is symmetric. Also, the mean, median, and mode are all the same. So the mean is 30, the median is also 30, and the mode is also 30. All of them here in the middle. The mode is the most frequent, and the median is also here in the middle. So for a bell-shaped, mean, median, and mode are equal. And also, uh, it's a unimodal. Yeah, the graph is unimodal. Unimodal means there is only one peak at a single value. So this is the peak, one peak. We don't have two modes. It's only one mode. And the x-axis works as an asymptote of the graph. So this is the x-axis. This is the axis of the variable x. 40 is a value of x. 20 is a value of x. Zero point 0.5 is not here. Zero point 0.5 is not, it could be here if you like. It's between 0 and 10. You can find 0.5 here. But the area is not value of x. So there is a difference between x values, which you can see on the x-axis, and the areas or the probabilities, okay, which is the green, the area under the curve. So the graph becomes closer and closer to the x-axis, which means x is a horizontal asymptote. Also, the variability changes, the spread changes when we have different standard deviations. Let us talk now about the standard normal distribution. So we have infinitely many normal distributions. When you change mu and sigma, you get a new normal distribution. We have infinitely many normal distributions. Let us choose one of them and call it the standard normal. So what is the definition of the standard normal? We will choose mu for the standard normal to be 0. Once you determine mu and sigma, you determine the normal distribution. Sigma will be chosen here also to be 1. So if sigma is 1, this means that the values of z, and we will call the standard normal z, all other normal distributions are called x, only the standard normal would be called z, and you can see here that the values of z are mainly between -3 and 3, because if you go 3 standard deviations to the right and 3 standard deviations to the left of the mean. So as you remember also that between in any normal distribution we have these percentages, 68%, 0.26 in the first interval, and so on. Now, these are the characteristics of the standard normal distribution. The mean is 0. The standard deviation is 1. Uh, it is Z. We call it Z. Z values are on the x-axis, on the z-axis. It is the z-axis, not the x-axis. It measures the number of standard deviations a point is from the mean. So when you say Z is 2, this means it's 2 standard deviations from the mean. Values above the mean are positive, values below the mean are negative. This is 0, here positive values, here negative values. These are the characteristics of the standard normal distribution. Now we have a table for the standard normal distribution. This is the table. It's called the standard normal distribution table. If you Google the standard normal distribution table, you will find different tables are given. Okay, so we can deal with any one of them. Uh, I need only this graph. This graph will illustrate to me how the table works. Okay, we will deal with this table because that's the one in the book, and try to understand this graph, because if you understand this graph tells you how the table works. Okay, so what is this? This is the Z value. This is the Z value, and 0 is the mean. So this is the standard normal, and this is one value of Z 0.52. And here in this region, from here to here, Z is between 0 and 0.52. So the values of Z are between 0 and 0.52. What about this area? What is this graph? This area, what is this? This is the area between uh, 0 and 0.52. So this is the probability. Area is the probability. The probability that Z is between 0 and 0.52. Okay, so this, the green, is the area between 0 and 0.52. What is this area? We can find it from the table. So the table gives you areas where Z is between 0 and a positive number. Okay, this here you have Z, and here you have the values of Z. It starts from 0 up to 3. So it deals with all the positive values from 0 to 3. For example, if you look to 0.5 in the table, it will give you 0.5 will give you this area. Okay, if you look to 1, it will give you the area from 1 to 0. Okay, that's the areas given in the table. So if you look to 0.52, this is 0.5. If you need the second decimal, this would be given here. So 0.50, 0.51, 0.52, that's the number. 0.1985. So what is 1.1985? It is this area. This area is equal to 0.1985. And it is also the probability that Z is between 0 and 0.52. So the table gives you areas like this. It does not give you this area. It does not give you this area, okay? But this area is known. I know that this area is always 0.5 because we have studied here that the area to the left of the mean is 0.5, and always the area to the right of the mean is 0.5. So this area is 0.5, and this area is given by the table, and this area, okay, let us say this one, A. How to find A? What is A? A is
Point
point
5
five.
minus the
Yes,
number.
yes, point 0.5 minus 0.1985. So you have different areas here. You have to understand each one of them. This one is given by the table. This one is, if you need this one, it's zero point 0.5 minus 0.1985. This one is zero point 0.5. And we will see now, we will ask questions about different areas, how to find them using the table. So once again, the table gives you the probability that Z is between 0 and a number. So if the number is 2, you go to 2.0 because point 0 here, you write the area. So 0.4772 would be the area from 0 to 2. So you can sketch a graph here. This is Z, this is 0, this is 2. So this area is 0.4772. If you need to find this area, it would be zero point 0.5 minus 0.4772. If you want to find this area, it is zero point 0.5. Let us solve some questions for a standardized normal distribution. So this is Z immediately. If he doesn't say standardized and he says probability of Z, immediately Z is the standard normal. It is known Z is the standard normal. If he writes X, then it is not the standard normal. Calculate the following probabilities. What is the probability that Z is less than 1.5? To understand this probability, it's good if you sketch the graph of Z. This is 0. Where is 1.5? Let us say it's a number here. This is 1.5. I know from here to here, this is 3. So this is 1.5. He needs which area now? Let us understand. What is this? What does this mean? How can I graph this area? This is an area. This is an area, okay? How can I graph it? Well, this is 1.5. Z is less than 1.5. This is Z. Values of Z greater than 1.5, but I need it to be less than 1.5. So if you need values less than 1.5, you will consider these values. All of these values are less than 1.5. Even this one, -1, -2, less than 1.5. So he is asking about all of this area, all of this area. Once you know that this is the area he needs to find, you can say, if you like, that this is the area to the left of 1.5. So he is asking about the area to the left of 1.5. The table will give me this one. And I know that this is 0.5. So the probability that Z is less than 1.5 would be 0.5 plus, this is the 0.5, and this would be given by the table. How to find it by the table? I look to 1.5, okay? So I go to the table, look to 1.5, this is 1.5, the number is 0.4332. So this area is 0.4332. So the area to the left of 1.5 is 0.5 plus 0.4332, which is 0.9332. This is the area to the left of 1.5. If he is asking about the area to the right of 1.5, I can find it, for example, 1 minus this, or 0.5 minus 0.4332. I leave this for you. Please try to do it. And let me solve part C. To understand always the probability, please sketch a graph. It will help you. So this is the graph of Z, the standard normal. This is 0. This is -1.28. It's a negative number, so it's to the left of 0. This is 1.75. It's a positive number, so it's to the right of 0. Z is between these two numbers. So he needs all these values, okay? So he is asking about this area. What is this area? How can I find this area from the table? I can find this directly, immediately from the table by looking to 1.75. If you look to 1.75, this is 1.7, and you go to 5, this is 5, so 0.4599, 0.4599. So this area is 0.4599. Now what about this one? There are no negative values in the table. Yeah, but if you have, that the graph is symmetric. If you need to find the area from here, this area, you can just look to 1.28. And if you look to 1.28, it will give you this area, but this area is equal to this area because the graph is symmetric. So to find this area, you just look to 1.28. So if you look to 1.28 in the table, this is 1.2. And if you go to 8, this number 0.3997. So this area is 0.3997. I need the area from here to here. So I just add these two numbers, 0.3997 plus 0.4599, and I write the answer. Some other examples, you can find this immediately from the table directly because z is between 0 and 2.33. Just look to 2.33. And this one is similar to C. In fact, it is easier than C. Let me solve this part for you. And notice the difference. Here I have a negative number and a positive number. Here I have two positive numbers. Will there be a difference? Sketch the graph and you will see if there is a difference or not. This is 0. This is, let us say, 1.78, and this is 2.34, and I need this area, the area between 1.78 and 2.34. How can I find this area? Well, I can find this area from 0 to 1.78 by the table. So I can look to 1.78 in the table and find this area. If you look to 1.78, this is 1.78, so 0.4625, 0.4625. So this is 0.4625, and this is of course zero point 0.5 if you need it. You may not need it. Okay, now I cannot find this area from the table. I have this one. So how can I find this one? What if I give you the area from here to here? Can you find this area from here to here? Yeah, by looking to 2.34. So if you have this area from here to here, and you have this area, by subtracting them, you will get this area. So how to solve this question? You go to 2.34 and you find this area, you call it A1, and then you go to 1.78 and you find this area and you call it A2, and then this area would be A2, this area would be A2 minus A1. So look to 0.34, this is 2.3 here, and 4 would be this number, 0.4904, 4904. So this area is 0.4904, and the area between these two numbers would be 0.4904 minus 0.4625, and you will get the answer. So notice that if the two numbers are positive, you subtract the areas, while if one of them is positive and the other one is negative, you add the areas. If the two areas are negative, you also subtract. It is similar to this one. In fact, you can deal immediately with the positive numbers if you have negative numbers because of the symmetry. This one you can find directly from the table. And here you have two positive numbers. Please do the same process which I taught you. And this one, negative and positive, you will add the two areas. Greater than -1. Let me try this one and this one. Okay, let me try B and E. So how to find the probability that Z is greater than 1.645? Let us sketch the graph. Okay. This is Z, this is 0, and this is 1.645. He is asking about what? Z is greater than. So he's asking about this area. This is the area I need to find. We mentioned that this is zero point 0.5 and this would be given in the table. So this area would be zero point 0.5 minus the area here. Minus the area here. So now look to 1.645. Look to 1.645. Well, in the table, I have 1.64, this one, and 1.65. I do not have 1.645. So what to do? If you need 1.645, you take the middle area, okay? So if you take the middle area between these two numbers, this means you find the average. You add the two numbers, and then you divide by 2 to find their average. The average would be 0.45. So this area is in fact 0.45. So this area would be zero point 0.5 minus 0.45, and that would be the answer. 0.05. Let us conclude by the graph of this, by the probability of z greater than -1. Notice here that -1 is to the left of z, and he needs z to be greater than. So he is asking about all of this area. We know that this is 0.5, and we can find this from the table. How can we find this from the table? By looking at 1, because the area from 0 to -1 is equal to the area from 0 to 1. So if you look to 1 in the table, 1 is 0.3413, 0.3413. So this area is 0.3413, and the area to the right of -1 is 0.3413 plus 0.5 would be 0.8413. I hope that you now understand how to find any probability using the standard normal distribution table.